Okay, so now we understand that the proxy and the daemon are there to provide the transport that we need. And we have seen that on that transport, we can reduce the payload size from something very large to something very, very small. The question is, how do we do that, and how do we make that something that can be used in a general sense? And the answer to that is actually in the beginnings of what we call the unrest protocol. But what it really amounts to is sort of the the proxy, when you load it in, takes a look at the extension on the page that's coming in. It might be JSON. It also auto recognizes it so that it can recognize things that are in requests. But if it's got an extension, that's the best way to do it. But it understands that this is JSON, or this is XML, or this is plain text. And it has handlers for each one of those. And the handler is a generic pattern, right? It's when I looked at it, I realized that that what the what the web server was doing was loading a codified pattern, and that if that pattern had a documented a documented protocol, that then we could write a parser for that, and that if we could write a parser, then we could write a compressor. And when I say compressor, I don't really mean compressor, because it's a compressor implies you're sending over all the bits. We're not. We're just sending over the things that changed. But I understood that each one of those things was going to be different. The way that you would do it for XML would be different than the way you would do it for JSON, would be different from the way you did it for HTML. So we made it a factory pattern, right? We went with object-oriented programming techniques and made it a factory pattern where you recognize the data type, you register the data type, and we call basically what amounts to a function where we pass in the buffer that was given to us, right? So we pass in the page, or we pass in the request string, and we get something back, right? What we get back is up to what that compressor function does. So we call the set bytes function, and that's not the name for it. I don't remember the actual name right now, but we call the set bytes function, and what it does is it takes the incoming buffer, and in the case of XML or JSON, for example, it applies the JSON rules and says, okay, this is a tag, this is blah blah blah, and it looks at the cache data that was there, and it says, okay, these things have changed. So what it generates then is the map and the bytes, and it puts those on the wire. That's its return, is strictly bits, right? Bytes. Those go on the wire, and they go across to the other side where they get picked up, and they get sent into the expander routine. And the expander routine looks at those bytes and looks at the map and does exactly the opposite. And its return is a string, which is the uncompressed string. So we take the compressed string, bring it in, do the thingy on it, and that what that thingy is up to the language, up to the registered function, the factory pattern for that handler, right? And so we have handlers written for JSON, XML, HTML, CSV, and plain text. And it brings that back, and those are the bytes that go on the wire. You can put anything you want to in that function, in those two functions. I mean, anything. It doesn't matter. You can take whatever strange string you want and return whatever strange bits you want. We'll put them on the wire. We'll send them over to you on the other side, and you can rebuild whatever strange string you want. That's the flexibility of the system, right? We built it so that it would handle JSON and HTML and XML, but it can be built just as easily to handle proprietary languages or to do secrets. If the phrase the lazy dog jumps over the moon is seen 4 times, that means that we write at midnight, or something like that, right? You can do whatever you want to with it because it's up to you, and the thing that goes through there is entirely under your control. So what I've done in there is set up a protocol that lets you do this as a beginning, and we move it forward from there. So Song of the Frogs, which is the protocol that implements the communicator, right? That is a protocol that comes through that lets us do high speed uh, video transmission over TCP/IP, and that's a registered type. And when we get a message of that type, we notify the appropriate handler, and that's the way it works, right? You can do that with anything. You can send messages and have them notify handlers, and the handlers can do whatever they need to do with those messages. It's entirely under your control. So this aspect of the system is probably one of the most powerful things that you're going to find inside it, in terms of what you can do with the system and how you can customize it and bend it to your own will. Uh, and when you combine it with the rest of what we've built into that factory pattern, where you can say, my host needs to have these attributes. It must be this kind of machine, or it must have this, and I must have this system installed on it. Or you can say, my when a database host changes, we need to have this callback function so that we reassert ourselves to the new database host, and then we reestablish our state, right, based on the new current memory. So that's an important thing, because if you're doing something where you're trying to be consistent, even when you drop off and come back, right? So if, let's say, your node breaks from the rest of the network, and you become a one by yourself, you need to be able to have everything resolve and work, and then when you join back, have everything come back and still resolve and work. And that happens because we have rules that say this, the rules are like the database host rules and the media host rules. And they say the service that is dealing with these kinds of messages for us, for example, the service that's dealing with the Song of the Frogs messages is found here. And it has these attributes. And that's a calculated value, right? That's something that you set based on the information that's in the shared database. So the whole thing folds in on itself, and it all comes back to itself. But it gives you a lot of power and a lot of ability to put in custom protocols for anything that you want to, custom handlers for your own kind of messages or messaging, and you're doing it all on your own offline network that is invisible to the regular internet and is running at high speeds. There's no reason you can't combine what you're doing in your custom protocols with the compression, the semantic compression that we use for JSON and the like. It's all something you can stack. So it's all factory pattern. You just build it and go the right way, do what you want to do. So that is the basics of what we call semantic compression. Then it is that we have an intercept on all HTTP traffic through the FrogNet host. That intercept looks at the destination address of the message. It establishes a permanent connection between the proxy and daemon pair uh, on the two hosts that are serving those those two web servers, and then it pays attention to the the template, the data type of the payload, and creates appropriate templates and cache entries so that when we send things across the wire and bring them back, we are sending only the diff that we need to change, only the diff that we need to send. And that's all done cooperatively, but independently. So that if we split, if we rejoin the network as it merges itself, every time we do a merge, the network forgets everything that it knew before and starts over again. Every merge is clean. And so at the end of every merge, it reevaluates all the hosts, and it does it based on what it sees as the current set of hosts that it knows about and what their machine capabilities are. So that's how we go from where we are to orchestrating something like the way that the communicator works. Okay, that's the basics of semantic compression. The next thing we will take a look at, I think, is the transient database and how the transient database and tuple space form FrogNet shared memory. That's a very interesting discussion, and I think you're going to really enjoy that. So see you over there. Have fun. Bye.